Good morning, students. In the last class, we have studied the physical quantities and classification of physical quantities. In this class, we have studied the application of dimensional analysis. Application of dimensional analysis. There are three uses of dimensional analysis. One is check the relation, second one is derive the formula, and third one is conversion of a physical quantity from one system to another system. So first one is check the relation. Number two is derive the formula. Number three is conversion of a physical quantity from one system to another system. So first one is check the relation, second one is derive the formula, third one is conversion of a physical quantity from one system to another system. First we discuss about the check the relation, but before going to check the relation, all the three applications are based on one principle, and that principle is known as the principle of homogeneity. So first we know what is principle of homogeneity. Principle of homogeneity. This principle states that dimensional formula of every term of a two sides of a relation must be same. Principle states that the dimensional formula of every term of a two sides of a relation must be same. We know in a relation there are two sides, one is left hand side and another is right hand side. In LHS or RHS, both the sides, number of terms are there, but we have to, if the dimensional formula of two sides of a relation same, then the relation is correct, otherwise it is incorrect. So first we will go to the check the relation. First we will do one example of check the relation. B equal to U plus A. In this relation, four physical quantities are there. One is V, that is final velocity of the particle. Second one is U, initial velocity of the particle. Third one is acceleration of the particle. And fourth one is time. First, we find the dimensional formula of four physical quantities. First, V. So L to the power 1 to the power minus 1. Similarly, dimensional formula of U equal to L to the power 1 T to the power minus 1. Dimensional formula of A equal to L to the power 1 T to the power minus 2 dimensional formula of T equal to T to the power 1. To find the dimensional formula for quantities, first T equal to L to the power 1 T to the power minus 1, U equal to L to the power 1 T to the power minus 1, A equal to L to the power 1 T to the power minus 2, T equal to T to the power 1. So in the example, left hand side is B, so we write L to the power 1 T to the power minus 1. On the RHS side, two terms are there. First term is U, second term is A into T. So what is the dimensional formula of U? L to the power 1 to the power minus 1. The dimensional formula of second term A equal to L to the power 1 to the power minus 2 and T is to the power 1. So write L to the power 1 T to the power minus 1. So we see that the left hand side dimensional formula is equal to the right hand side. That means all the three have same dimensional formula. So we write LHS equal to RHS. Therefore, the given relation is dimensionally correct. This is the first example of check the relation. Next, we find another example of check the relation. Second example number 2. T equal to 2 pi root over G by L. So here there are three physical quantities. One is T, second one is G, and third one is L. T is the time period of a simple pendulum, G is the acceleration due to gravity, and L is the length of the bow. So first in LHS, we find first the dimensional formula of T, that is equal to T to the power 1. The dimensional formula G equal to L to the power 1 T to the power minus 2. Dimensional formula L equal to L to the power 1. After that, then the LHS side, what is that? T. That is dimensional formula equal to the power 1. In RHS, what are present? 2 pi and root over G by L. Here 2 and 5 both are constants and known as dimensionless constant. That was studied in the last classes. So root over G by L means G by L to the power half, which is equal to L to the power 1 to the power minus 2. That is the dimensional formula of G, and dimensional formula of L is L to the power 1 and to the power whole to the power half. So what is the answer? So 11 will cancel each other, and T to the power minus 2 to the power half equal to T to the power minus 1. So here we see that in the case of LHS we find the dimensional formula T is T to the power 1, but in RHS we see that it was minus 1. So therefore LHS not equal to RHS. So therefore here the given relation is dimensionally incorrect. Okay, so we see that b equal to u plus 80. Here the dimensionally correct relation. Here this is the dimensionally incorrect relation. This is all about the check the relation. Next we discuss about the second application, that is the derive the formula. So we have to know how to derive the formula dimensionally. The question is find out derive the formula centripetal force and the particle is moving in a circular path of radius r, mass m, and velocity v. So question, what is the question? Derive the formula of centripetal force when a particle is moving in a circular path of radius r with mass m and velocity v. So we will find out the formula of a centripetal force, and what are they? Now particle moving in a circular path whose radius is r, whose mass is m, and velocity is v. So solution: first we have to know what are the factors centripetal depends on here. So centripetal force is Fc, right? So what are the factors? Mass to the power a, velocity to the power b, and radius to the power c. This is the equation number 1, equation number 2, and this is equation number 3. A, b, c are the constants. So combining all the equations we get Fc proportional to m to the power a, b to the power b, and r to the power c. That is Fc equal to k, m to the power a, b to the power b, r to the power c. Where k is the constant, dimensionless constant. K is the dimensionless constant. In the second step, we put the dimensional formula on both sides. And equation number 4, putting the dimensional formula on both sides of equation 4. So Fc What are the dimension of force? N to the power 1, N to the 1 to the power minus 2 equal to K dimensionless constant. So N to the power 0, N to the power 0, N to the power 0. N mass to the power A, velocity 1 to the power B, and radius N to the power 1 to the power C. So solve the equation by M 1 into A, L 1 into B, T minus 1 into B minus B, and here L to the power C. So again we write M to the power 1, L to the power 1, to the power minus 2. Total M in the RHS 0, A. So 0 plus A, L 0 plus B plus C, so B plus C. T 0 minus B. This is the equation number 5. In next step, what we will do? Equating the coefficients of M, L and T. So A equal to 1, B plus C equal to 1, and minus B equal to minus 2. Here you see that the value of A is 1. Here minus B equal to minus 2, so B equal to 2. And what is the value of C? Value of C find by this equation. 2 plus C equal to 1, so C equal to minus 1. Putting the value of A, B and C in the equation number 4. Putting the value of A, B and C in equation number 4. So FC equal to K M to the power A, that is equal to the power 1, B to the power B means B to the power 2, and R to the power C means R to the power minus 1. So K M B square by R. This is a dimensional equation. What we have to take constant K equal to 1. So FC equal to M B square by R. This is the required expression. This is the required equation. In the next class, we will study another example of application 2, that is derive the formula, and application 3. Thank you.